Thank you for coming to Game Development with SDL 2.0. Please welcome to the stage Ryan Gordon from Icculus.
All right, thank you very much for coming. Okay, let me start the little clock here so I don't talk super fast again. Is it going? Maybe. No, it's not. Okay, we're going to just go ahead and start then. Oh, there it goes. Okay. Okay, so my name's Ryan. This is a talk about Simple Directmedia Layer 2. We'll have lots of slides for you to look at. Okay, so just a few notes to get started here. Feel free to interrupt at any time. If you have a question, raise your hand. I'll try not to ignore you. I can actually see because the lights are not in my eyes this time. If you ask something interesting, we might have a totally different talk and the slides we'll just abandon. So don't be afraid to volunteer if you have something you want to ask about. These slides will be at that URL later today. I'm going to upload them as soon as this talk is done. This is just a high-level overview today. We're only going to talk about what SDL can do to make your life better. I don't think there's a single line of code in this entire slide deck, so don't panic about that. Just try to walk out here understanding what you can do, and then you can, go home and do awesome things with it and look at the documentation and stuff like that. If you want to tweet during this, that's my Twitter handle. I will see it later. If you say nice things, I'll smile. If you say mean things, I'll probably cry, and that might be worth doing to me too. Okay, so who am I? My name's Ryan. I port stuff to Linux and Mac OS and the toaster oven in your apartment. I do that for a living. I've been doing it for 15 years. I've done it for a lot of big games, a lot of little games, and a lot of everything in between. I build tools when I'm not porting games that make my life easier. I'm not going to talk about them today, although there's a lot of self-promotion I could do if I felt like it, but I'm not going to because that's not what we're here for. I'm a freelance. I do this for myself. I don't work for another company, and I've been doing it for 15 years. Just to give you an idea, this is what my NASCAR jacket looks like. Lots of people, lots of big companies, lots of little companies, lots of games, et cetera, like that. This is my biggest client right now. This is my daughter, Olive. Okay, so anyway, enough about me. SDL, we call it, oh yes, question. Are
you the guy that Humble uses to port everything to everything?
I am one of the guys that Humble uses to port everything. One of the other big ones is sitting right in front of you right now.
And the other one is right there.
Oh, and the other one's there. We're all here. It's like a big cult or something. Okay, so anyway, Simple Directmedia Layer, we call it SDL, just assume that media is part of the second word, so it's a 3-letter acronym. Simple Directmedia Layer, it's our open source answer to DirectX. If you were writing a Windows game from scratch, you would reach for DirectX, probably. You would want the video from it, the audio functionality from it, et cetera, depending on what year you're developing your game in. But outside of Windows, in Mac and Linux, SDL is very popular because they don't have DirectX, of course. This is an equivalent to it. It's not the same syntax, it's a different library, it's not the same set of functions, but it will give you roughly access to the same stuff in a much, I think, easier way than DirectX does, and the fastest way it can, and also the development time fastest way it can. It's cross-platform, it runs on darn near anything. We're working with SDL2 right now, and we've cut back to some more modern, recent platforms. The previous version ran on everything from Amigas to Dreamcast to Palm Pilots and things I haven't even thought of yet. Just ridiculous numbers of things. And in the current generation, it runs on lots of stuff you actually care about in 2014. It's powerful, it's fast, it's easy. It's also had 15 years of development, much like me. It's been maintained and heavily enhanced and improved and bug fixed for a decade and a half now. Many games have used it, many games over the years, millions of gamers. All of Valve's games are shipping, they use SDL. The Steam client itself uses SDL for certain things. Lots of other games you've probably played. If you played it on Mac or Linux, you almost certainly used SDL. If you played it on Windows, you might have used SDL. Okay, so, and the website for it is www.libsdl.org. All these links will be on later slides, and these slides will be available for download too. Okay. Brief history of this, it was started by Sam Lantinga, who is sitting in the audience. There he is, okay. He started for a program called Executor, which was a Mac OS classic clone emulator. It would run things, it was awesome. And that's where it started, and it made just a nice, easy way to get this cross-platform way to get bits to the screen and stuff like that. And then Sam got hired by Loki, and all right, there's Loki employees here too. Loki adopted SDL as kind of its framework to port games to Linux with, because what they did for a living was port games to Linux, and they spent a great deal of time, and a whole staff of engineers spent time improving and enhancing the framework. It's kind of now a de facto standard. If you want to write games on Linux, this is probably what you're using already, and if it's not, it's what you should be using, and we'll get into why later. And we just shipped the past couple of months, we shipped SDL 2.0, which is the new hotness. It has a lot of new features. We're not going to talk about SDL 1.2 today, except to make fun of it, but 2.0 is what you should be using. It's open source, it's freely available. You can download it and play with it right now if you want. Not right now because I'm talking. But okay, so here's some basic features you can expect from SDL if you were to pick this thing up. It targets modern OSs, your Macs, your Windows, your Linuxes, but also your iOSs and your Androids and stuff like that. It's a portable game framework. If you write something to target SDL, it will probably just work across all these platforms without much fuss, depending on how much SDL you put into it. It's got multiple API targets, which sounds like a weird thing to say, but let's say that you have, well, we'll talk about that later. It's important, but I have a whole slide about it. It makes hard things easy. That's the simple part of Simple Directmedia Layer. There's lots of things that game developers do, and they cut and paste boilerplate because it's just kind of hard to do and hard to do well, and it's solved as ugly code. We like to take those things and make sure you don't have to write them. We took care of all that nonsense for you, and I'll show you what I mean in a moment. It's written in C. If you're a C++ programmer, we don't judge you, but there's a lot of benefits to it being written in pure C, not the least of which is when we started, C compilers were even awful and C++ compilers were even worse, but it lets us make it very easy to plug into scripting languages. There's a very highly maintained Python interface for SDL that people like a lot, for example, and that was made easier by having C instead of C++. And if you like Lua, if you like, you name your favorite scripting language, there's an SDL binding for it, and being written in C helped that. It's licensed under the zlib license. Has anyone ever read the zlib license before? Only one of you. It's a good thing I put it on a slide. Don't read this. This won't be on the test, but I'll give you the basic rundown of what this means. More or less what this says is we don't give you a warranty on it, so please don't sue us if it breaks for you. We like if you tell people that you use it, but we don't legally require you to, and don't take our name off of it. That's it. That's the entire license. Now, the older version was under the GNU LGPL, and we removed all the code from that. We changed the license. We made sure we had permission to do this because we found that the LGPL is really, really scary for developers. And even if you could use it with closed source stuff, it was questionable and people got nervous about it. This is it, man. This fits on a Post-it card. It fit on a PowerPoint slide. So we thought this was much easier. I was going to put the LGPL license on here, but it took 22 slides at this font, so I decided not to. But basically what that says is you can download it, you can modify it, you can statically link it, you can do whatever you want with it, and we're happy that it's useful for you because it's been useful for us. So I mentioned this runs on a bunch of different platforms. This is our currently supported list of platforms, and this varies from day to day, but of course Linux, Mac OS, and Windows are the big three on the desktop. We support them all. I do all my development on SDL under Linux, unless I'm specifically focusing on a platform thing, but we also have people working on Windows and Mac OS. They're all important and functional platforms. I put Unix up there because if you're still running Solaris or you have FreeBSD or something, those are also supported. Android and iOS, because the mobile market is where we're all going to do our gaming someday, whether we like it or not. Haiku is actually a newer version of BIOS. Just to give you an idea, we wanted to keep it so we had flexibility, so we could show how portable this was. And of course, the Raspberry Pi, that little $35 device, it will actually run on that and get OpenGL ES support on it. Other interesting places, it pops up in places as new ports show up, we take them in, and it's good. And it's 64-bit clean, it's Endian clean. You can probably get to a new platform fairly easily. It has a lot of subsystems. Now, for SDL 1.2, this slide was 8 bullets. This one is 16. Some of these I'm going to go over in great detail for most of this talk, but just to give you an idea of what you can do with SDL, it handles your video stuff, how I get bits to the screen, how I create windows, how I manage my windows, how I get audio PCM data to the audio card, events like when you click a mouse button or hit the joystick or something like that. It has a very simple 2D rendering API if all you want to make is a very simple game, and I'll talk about that in detail later. Joystick support, a higher level game controller support thing, so you don't have to screw with the details of all the weird joysticks you might see in the field. Haptic support, which is force feedback. That handles a lot of platform stuff that you've probably written platform-specific code for that would be nice to rip out, like, how do I load a shared library? You can take that if-def out of your program, and what kind of processor am I running on? Does it have SSE 4.2 support? Things like that. And things like wrapping up threads and stuff like that, and how do I find out that the laptop's running on battery, etc. We're going to talk about this stuff. Okay. I said before it has multiple API targets, and oh yes.
Talking about ports before you move on, what do people do about Expo and PS4, PS3, 360? Is that noticeable around?
We'll talk about that a little later. Yes, what about like consoles like Xbox and PS4 and stuff like that? We don't have a specific plan for that at the moment. We're thinking about how to solve that problem. Okay, so multiple API targets. I said this before, and some people were probably like, I have no idea what that string of words means. So if you run on Linux right now. How many of you are Linux users? Okay, wow, a good portion of you, that's great. As you know, you have an X server that is used to do video, but as you might know, there's also something coming called Wayland, and there's also something coming called Mirror, which will change the way that we talk to the video card and hardware and stuff. So if you were to talk to X11 right now, next year your game may or may not work. It may not even start, depending on how well Wayland and Mirror end up handling that. And certainly anyone that's been a Linux user for a decade or more has found out that no matter how you like to talk to the sound card, it changes every now and then. They come up with a new API. So what SDL does is it does not actually link to any of these things. It does not link directly to Xlib. It doesn't link directly to ALSA for audio. What it will do is use DLOpen, and for you Windows developers, that's load library. It'll look for the shared libraries, the DLLs on your system that might match what a user has, and it'll try to figure out the best path to get to their video card and their audio card and what technology is available on that system, and it will do the right thing. And if we prefer to have Wayland, but they only have X11, we'll try Wayland and say, oh, there's no Wayland support in the system, and move on to X11. The user's no wiser. Your game just came up in a window and played like you'd expect it to without you having to think about it. And we do that for all the subsystems in here. There's nothing that SDL links against except the standard C runtime. And on Windows, we don't even link against that. So, And like I said, I'm sitting here poking at Linux, but every system has this sort of API problem. On Windows, if you like to talk to the sound card, the way you do it has changed many times over the years. You could have been doing Wave Out or Direct Sound or Xaudio 2 or maybe Wasapi or whatever. It might change again in Windows 12. Who knows? We'll find out. So the next thing I talked about with this was that how simple it was. This is the Simple Directmedia Layer. So I wanted to give you a demonstration here. Like, how many of you are Windows developers? We're going to change you all. I'm glad you're at a conference about SteamOS. This is the right place to be. You're going to learn a lot today. If you've ever done Direct3D and you've talked directly to Direct3D without any sort of framework in between handling it for you, this is a dirt simple Direct3D example of how to get a window on the screen so you can start drawing 3D stuff. Okay, here we go. You ready? Okay. You got to get a window class, and you got to register that, and then, oh, well, I'm not done here, hang on a second. Then you got to see what kind of properties the video card has, and get this frame buffer format, and that refresh rate. Oh, can it do 3D hardware? We're not actually sure at this point if you actually have a 3D video card. Let's see, and then you got to do some other stuff, and let's see. Okay, now we have a window. Now we actually have a way to draw 3D on the screen. That was 4 slides, and the font was getting smaller, and I did that ironically. This seems like a pathological case, but this is actually how they recommend you do it in the Direct3 3D documentation. This is not something I made up to make them look bad. But they make themselves look bad, because if you could actually read this on this slide, there is no error checking in that example. This actually goes on much longer if you have to check for failure cases. A look of disapproval about that. I'll give you the shifty eye for that. Here's the really hard SDL version. You ready for this? There you go. That gets a window on the screen, and you are ready to start drawing 3D content. Period. Point blank. Done. As you can see, there's a flag if you want a full screen window that takes over the whole desktop, and you can just do a window if you prefer. That's a 640 by 480 window. Done. Oh, the little title bar that says hello. So I use this as an example. I don't mean to poke fun at Direct3D, except it's incredibly easy. But this is kind of how we built the whole API. So a lot of things that you've looked at and said, give it to the intern. This is much easier and much more satisfying as a programmer to work with over time. So I use that as an example, but the entire API is structured this way and a lot of functionality. Question? Oh, look of disapproval. I don't have any error checking. That's true. I don't. As an exercise to the viewer, you can add the 2 if statements here. Okay, so you might have seen on this slide, we have SDL init as that first call, and this is, I think, the only code in this whole demonstration. So you can see there's a flag to it, SDL init video. You can also say, I also want the audio layer, they're bit flags, you just OR them together, and you pick the subsystems you want, and you ignore the subsystems you want. So for example, if you're using some third-party audio library, like you have Fmod in your thing, or you're using OpenGL or Miles Sound System or something like that, just don't give us the audio flag, and we won't try to even look at the audio hardware. So, and there are some exceptions to this. Some things are a little weird. Like if you want to get like mouse events, of course you need to have a window, so you have to have the video subsystem, and they're clumped together like that. But for the most part, you can pick and choose what you want, and if you're statically linking, you don't even have to have the parts you don't want in your code. But don't statically link if you don't have to. I'd recommend you not. Anyway, but you can make it so it doesn't touch the hardware. So the other things you do want to use, like a third-party audio library, can do it without us interfering. Okay, the video API. This is really kind of the bulk of the exciting stuff because pixels are pretty, right? It's really simple. You get multiple windows, multiple displays. If you have someone that has 3 displays hooked up, we can enumerate them for you, tell you, roughly where they're positioned in virtual space, what different modes they can be set to if you need to change the resolution on any of them, etc. like that. You could put different windows on different displays or different windows on the same display if you want to have a game with more than one window. This is new for SDL2. In SDL 1.2, you can only ever have one window because that's what most games want. But SDL2 was about removing those kinds of limitations. So now you have a lot of power. You can build some very complicated things that aren't necessarily games on SDL2. It's there, the way you draw into that window, you have lots of options. You can do software rendering into it if you really want to, but OpenGL, GLS, Direct3D, all we want to do is get you a window on the screen and get out of your way so you can use your rendering API of choice. It makes OpenGL context management easy, which is to say everything I just made fun of with Direct3D there, if you're talking to WGL or GLX to get an OpenGL context, those things are also kind of ugly, but we actually make it one function call. We just say, a couple of function calls. You set the basic attributes you want, and then you say, I want like this much, this color depth and stuff like that, and then you say, give me a context, and it goes, okay, and it figures out all that for you. Did you have a question?
Does it also handle lost context, like what you trace on
We have stuff in the pipeline for that, but it's not made it into a release version yet. But it's a feature we're thinking of adding soon. You want to know if you can deal with lost contexts in OpenGL. And Direct3D, obviously, we just give you the Direct3D device, and you can check that yourself. Question?
I was going to ask this about 5 minutes ago when you mentioned it ran on a Raspberry Pi. What is the overhead? Like, how thin is it?
That's actually a really good question. He asked what the overhead was for SDL, and the answer is a function call or two. We mostly stay out of your way, and it's mostly a very thin shim that figures out what the platform wants and goes directly to those platform calls. It's not even like a whole collection of if statements. Like, was this Wayland? Was it X11? Was it a Raspberry Pi? They're all function pointers. We jump into the right one, and your overhead for using SDL, it won't even show up in a profile. What will show up is perhaps when you swap frame buffers as on OpenGL for the system, but that has nothing to do with SDL. You have that anyway. So the overhead for SDL is incredibly low in terms of like function calls and CPU time. The video API, let's get back to this for 1 second. The video API exposes GUI events like when you mouse over things, lose window focus, the things you would expect to have to do with like a Windows message loop or something like that. It's fairly simple. I'll give you, there is one other piece of code in here. I'll give you an example of what that looks like a little later on. And of course, message boxes, which seems really silly to be like, we support message boxes. But those are actually really hard to do on some platforms. You would be incredibly surprised. So we actually have an API that will figure out how to get just an error dialog on the screen if you need one. So sounds ridiculous. One function call that will save your life. Okay. There's a couple of concepts that go with this video API. Windows are just what you'd think they are. They're windows. They're the thing on your screen with the title bar. You can set them to be resizable or not maximizable or have a border or not and stuff like that. Surfaces are 2D buffers of pixels that sit in system RAM. This was the only way we did things with SDL 1.2. Occasionally you could force them into video RAM for direct draw, but almost always they were on the CPU and we just forced it. If you need a buffer of pixels, they're always in system RAM now, and we call those surfaces. If you want them in video RAM, we call them textures, which is, I guess, probably everyone does. But and we have an API that uses that, so you can, even if you have a 2D software rendered game, you can push everything to the video card, and we'll get to that in a moment. And then, of course, OpenGL. We like OpenGL. we've taken great efforts to make sure that OpenGL works across multiple platforms with SDL. If you'd rather use Direct3D, you are totally able to do that. We will give you a Direct3D rendering device object, or we can also just give you the native handle to a window, and you can do whatever you want with it if it comes to that. And then you have to have all that boilerplate code I showed you before. Let's talk about this render API for a moment. We have a very simple 2D rendering API. And I say this, you should think of this as the most hyped up Super Nintendo you've ever seen. It'll do, think of it, you can get things into video RAM and then treat them like sprites, draw them wherever, scale them, rotate them, but we're not really interested in trying to compete with OpenGL. If you need more power than that, you should probably be using OpenGL directly. But if all you want to do is knock out a Super Mario clone or a very simple prototype, or actually a really good high-level professional game that just doesn't have really demanding graphics, this is an API that you're really going to want to look at, and I'll show you why momentarily. It handles, I call them sprites on this slide, but literally it's just texture sitting in GPU memory that you can just blitz the screen very quickly. It can do very simple blending, alpha blending. It can do primitives like draw a rectangle or a line. It can scale and rotate your textures, and it can do very basic color mods on them. So you can write simple games fast with it, and more importantly, you can make legacy games amazing. Everyone works for a company, well, some of you work for a company that in the 1990s shipped a really awesome 2D game when that was like, Direct Draw was new and stuff like that. I would love to see those games on Steam. I would love to see those games updated. And this is a really good way to get that game off of a software, take your software renderer and push it to the GPU, get Steam overlay for that game, get scaling for modern hardware so you're not playing in a little postage stamp window. You can do a lot of amazing things with it if you have a legacy game. So this is definitely something you should be looking at if you have something like, I don't know, Duke Nukem 3D or something like that. And if you need more power than this, you should use OpenGL. But I want to give you a very brief example here. There's a game called Dungeons of Dreadmore. Has anyone played this? Sorry, Nicholas. The guy who wrote it is here. It's a really great roguelike game. It's got 2D graphics. Here's what it looks like on Mac OS. Oh, sorry about my desktop. It's messy. What can I say? It's roguelike, but you'll note it's basically 2D sprites, more or less, moving around. They manage that and they draw them. And this used to be a 2D game that just wrote directly to a frame buffer, and we moved it over to SDL2 as an experiment, and now it does, all these sprites are in textures, they're all running on the GPU, fixing a major problem that they had with their Windows people, where the Steam overlay will not work if you don't use either OpenGL or Direct3D. But now, once we push this to Steam, the Windows version using SDL2 will suddenly have a Steam overlay that works, which is fantastic. And that's the Mac version using SDL2. It looks like the existing software rendered version, so it's not very exciting. But once we had this, we said, SDL is incredibly portable, and now we can take advantage of GPUs, so even on slower devices, you don't have to software render this stuff to do alpha blending, blitz, and stuff like that. So I wonder what it would take to get running on iPad. So we did. Total lines of code changed for this? 0. I mean, we had to port it to SDL2, to be fair. But once it was an SDL2 thing, this and this are the exact same code. And then we thought, could we take it further? Oh, look, there it is on a Raspberry Pi. 0 lines of code change. We didn't get it working on that Dreamcast at the bottom yet, but what can you do? But yeah, that's a Raspberry Pi hooked up to my television. As a disclaimer, Gaslamps Game asked me to tell you that they are not actually shipping this. Maybe they'll experiment with it, but we just did this for fun to see if we could do it. Don't start knocking on their door for the Raspberry Pi port. Okay, so, but the gist is, if you have a simpler game that has simpler graphics and you can move it to the 2D rendering API, that's all you have to do. And also, this is worth noting too, touch events on iOS, by default, will look like mouse clicks if you don't care to look specifically for touch events. So this worked with the regular mouse input. It thought it was talking to a mouse. It was actually me tapping on the screen. Okay, disclaimer, good. So if you want to use OpenGL instead so you can get more power, this is roughly what it looks like. I lied. There are code samples in this. I'm really sorry about that. If you get to, okay, so you create your window like we showed you before, and then you call GL create context and say, I need a GL context in this window. And then you're done, period. You can see if that failed. There's no error checking here either. I'm sorry, I'm a hypocrite all the way to the end. And then when you make your OpenGL calls, you draw, and when you want to swap buffers, you want to get that thing to the screen, you call SDLGL swap window, and then your OpenGL rendering's on the screen, period. Done. I just minimized how easy it is to use OpenGL, right? But as far as like managing OpenGL and the context management, that's pretty much all there is to it. And you can do more complicated things. You can create multiple contexts and share contexts and question.
So a number of you probably went to the NVIDIA talk where they talk about advanced design techniques with OpenGL, where you say
Yeah, as Sam pointed out, I just minimized that. And anything you can do with OpenGL, you can do where that comment is. You can get to incredibly complex stuff. You can write Crysis 12 right there. You can write Unreal Engine 14. You can do anything. All of OpenGL is available to you here at this point. And SDL will gives you very simple ways to say, hey, is this OpenGL extension supported? I don't have a slide for that, but it's literally one function call. I'm looking for this name, here's the string of it, is this a supported function? And it'll say yes or no. And then you know if you can call, the super new shader model 25 or something like that. So I don't mean to minimize it, that's actually really, really important. You could do incredible things. And between those two, the create context and the swap window where that comment is, all of Team Fortress 2 renders, all of, Painkiller, Hell and Damnation renders, etc. Serious Sam 3 renders there. Let's talk about events very quickly here. These are what you'd expect from any game that you might make. Input from the mouse, input from the keyboard, input from the window. Input from the window, such as, hey, the user just resized this. You can stop it from letting them resize it too. Don't get nervous. But all the things you would expect from a basic windowing system, we fold it down into very simple event loops that look something like this. Hey, give me the next event on the event queue. Is it mouse motion? Is it key down? Did the user ask me to quit the program, etc.? There's lots and lots of events you can look for, touch events and window resizings and other things I'm not even thinking of right now. But that's basically all there is to it. If you've ever done a standard Windows event loop, it looks a lot like that, but this event loop will work on every platform and figure out what the Windows event loop looks like or what the Cocoa event loop looks like on Mac OS, and your code doesn't change one bit. We try to figure out how to make it look like these abstract events. Go back here for 1 second. There's a touch API. Like I said, you can, if you have an Android device or an iOS device and you want to poke at the screen, we report those. By default, we will have touch events look like a mouse, but the mouse event will actually say, hey, this was actually a finger. Just so if you care about touch events, you know to avoid those. And if you don't, you just do the same mouse code you did everywhere else. You can do more complicated things like that. We can track multiple fingers at the same time, and we have a system in there we call dollar gestures. So if you can record very simple gestures, and SDL will tell you when the user has made that magic set of swipes on the screen as an event. Like, hey, he just did a something symbol. Joysticks and game controllers. We're going to talk about all this in much more detail, but if you just want to know, the guy wiggled his stick. He pushed a button, like you can get that information. And then we have a higher level on top of that that makes everything look like an Xbox 360 controller. Don't get scared, that's actually a good feature. Yes?
Does this include support for the Steam controller without having to hook into the magical Steam API, Steam SDK for it?
He's asking if it supports the Steam controller, and the answer is no, because the Steam controller looks like a mouse and keyboard. So you have to use Steamworks for that particular controller. Because to the OS, it doesn't look like a joystick. So, did you have a question? He asked if we support gamepads on iOS and Android through this API, and the answer is, I think, we have Android right now. I think that just landed. We do not have iOS yet because iOS 7 is the first thing that actually had a formal API for joysticks, and we don't support like the Atari CADE thing that was out before, but that is going in soon, and it will probably, if we're really lucky, I'll get that written for the next minor release, and it'll just magically work, same code. We'll just support it on that platform. But we do not have that yet, but it's easy to add. It doesn't take any changes to your code once we add it. Okay, and timers. You can set a timer and say, I got questions. Hang on 1 second. You can set a timer and say, fire an event every X milliseconds so I know to do something, whatever, and that'll just come through as a special timer event. I have questions all over the place. Hang on. I think you were first, so let's go with you.
So we shipped Baldur's Gate Enhanced Edition.
Okay.
SDL2.
Cool. Oh, great.
And for the Touch API, we ended up grabbing the pan and magnify events from the OS.
Okay.
Typing them down as their own events.
You should.
That cross-platform, or that this feels like an iPad.
Okay. Well, this is this guy was one of the people that shipped the new Baldur's Gate, which is an awesome game, and you should all play it if you haven't. He was saying that a year ago they used SDL2, which I'm going to first off say a lot of developments happened in the last year, so things may be better for this particular case, but they get touch events from SDL, but for swiping events, like you want to pinch and stuff like that to like scroll in, they actually went directly to the OS. This is probably something worth noting that I showed you Dungeons & Dragons running on iOS, and I'm up here like 0 lines of code changes, but you will probably want to do iOS-specific things. Now, that particular thing might be something we can handle better if we're not. We're open to looking at that.
And
But
it was actually, because of
Oh, yeah.
Came in and did it.
Well, that
Could
he
have patched later.
okay, good. Part of the reason they could do that, and this is part of the reason we changed the license, is it was hard to link LGPL code in iOS and not violate somebody's terms. So the zlib license changed that and made that feasible for an iOS port. But you may want to, even though you get the game running on iOS, you're still going to want to give it iOS love because people want it to feel like an iPad app. They don't want it to look like, a crappy port. And that's true if you're going from Windows to a console or vice versa. Everyone hates it when a Windows game has a little logo from like a PlayStation controller or so. Like, you are going to have to consciously clean up those things in your game. And your particular issue is something we might be able to handle better. But that's worth noting that we make you portable, but you still need to give it your own polish and make it a good program to run in the first place. Okay, let's move past events real quick here. The Joystick API, you can handle as many sticks as the operating system will report to us. So if your OS will handle 16 USB joysticks, you can plug them all in and we'll report them all to you. We'll let you know as they come and go. So if someone rage quits their game and yanks their controller out and goes home, SDL will let you know so you can do something. And if they walk them like, I want to play and plug in a controller, you can announce a new challenger approaches and stuff. That's all really great stuff. You can either pull the joystick, say, what does it look like right now, and just get like a basic state dump like you would get from X input, that kind of thing. Just tell me what it looks like right now. Or you can say, I want events. When every time they hit a button, send it through the standard event queue that I showed you before. And however you choose to react to that, you can use either option. They both work really well. And I've used both on different games. You can query for axes, buttons, hats, and the name of the joystick. So you can actually, this is a Logitech Wingman 3D, and you can actually get that string from SDL. And it'll tell you when things come and go. Now, that's the low-level API, and anyone who's ever dealt with direct input knows that this is kind of a hard API to use because there are a million joysticks out there, and they all look different, and they all work a little differently, and it's a little frustrating. So this works, but you spend a lot of time trying to decide where buttons are and whether it can work, and have to put up this configuration UI to let people calibrate their joystick, and it's a mess, and it's been a mess for many years. So of all the things that Microsoft has done well and not done well, the X-Input API was actually really useful as a model to say, hey, everything looks like an Xbox 360 controller, and they promise that by making sure it only works with Xbox 360 controllers. But that turned out, and that seems like a really awful, vendor antagonistic practice, but that actually turned out to be really good for a subset of games where you could say, I want this thing to look like an Xbox 360 controller. I wrote Super Mario. I want to know where left, right, up, and down is, and jump. And lots of games said, this is great in Xput, that I can just guarantee this controller will work the way I expect. So we built something similar, but we don't have that vendor lock-in. We built something called the Game Controller API. I don't know how to do emoticons in parentheses, so that's either frowny face in parentheses or a fat dude with, sadness. Everyone wants an Xbox. Everything wants an Xbox controller, especially if you're porting games from Windows. And you see this a lot in the AAA, but you're starting to see it also in indie games. Everything wants an Xbox controller because they wrote to X input and they built their whole game around that input model. So we gave you that. But we take it a bit further. What we've done is we started collecting game pads and controllers and all the weird things you can buy in the street corner in New York City that was made somewhere in China by the lowest bidder and has no actual discernible name. But fortunately, it has a valid USB vendor ID and product ID. So we look at these and we look at the GUID that is presented to the operating system. We say, we know what to do with that controller. We know this button's over here, this button's over here, it has 2 trigger buttons, and then we make everything, no matter what it looks like, if we can, we make it look like an Xbox 360 controller. So you still say, I want the X, Y, A, and B buttons, and we figure out what the hell that means. Now that seems like, did you have a question? Yeah. He asked if that handles adapter controllers for you have a Super Nintendo thing and a USB adapter for it. It can. Now keep in mind, if we haven't seen this before, the answer is no until someone sends us the basic information, and then it can. But now the model we went for this is literally an Xbox controller. Trigger buttons, shoulder buttons, 2 analog sticks, that are clickable, home, start, back. Did I miss any buttons on that? And the triangle and stuff. So basically, it will look like an Xbox controller, an Xbox 360 controller. I don't know what the Xbox One looks like at this point, but I'm sure it's probably similar. But as we see these things, we collect up a database. We have the more common ones. Like if you plug in a PlayStation 3 controller, it's just going to work. We know what to do with that because, it's a very common piece of hardware. But What we found, though, is that there are a million pieces of hardware, and we've never seen them before. So we said, hey, if only we could crowdsource this through millions of Steam users. So if you go into Steam with your really weird joystick and you go into big picture mode, there's a way to configure your joystick. When you do that, we take note of it and we send that configuration to Valve. Now, when we see enough of those, we know that's common. It's not someone trolling us, right? So at that point, we collect all these up and we can say, okay, now we have a good set of defaults. So when you plug that joystick in, if you've never configured it, Steam can make a good guess at what that joystick is and try to configure it directly, and it will pass that information to SDL when you launch the game. If it's not in there, you can do it yourself. We can give you a configuration program, or you can just configure it in big picture mode, and it will just work for you. There's an environment variable if you want to add stuff, and there's a way you can give it a config file and say, here's just all this stuff. Configuring this, I don't have it up on the screen, but it's literally just a string, a weird-looking string of like, this is, when you see button 1, that means button X, you know, and go from there. So that's actually been really useful for that, and a lot of joysticks that shouldn't just work with this now work, which is much better than the X input model, where you can get that simplicity if all you want is joysticks, game controller, gamepad simplicity, but you don't have to rely on having an Xbox 360 controller. Now, this also works on Windows, and on Windows, behind the scenes, optionally, we can use X input. So if you have an Xbox 360 controller, it will still do the right thing without you using X input directly. So this is an incredibly powerful API, and we're really proud of it, and you should definitely take a look at this if you're doing that sort of thing. It's a little less flexible than if you're doing the direct input model of tell me what's on this stick and I'll figure it out, but it works really well, and it just works simply without you screwing with it very well. And it's only getting better over time. Like, for example, as we find out that weird Super NES USB thing, we'll add it to the list and such like that. Okay, the Haptic API. Haptic is either Latin or Greek. I can't remember what for force feedback. Hang on a second. Question.
Yeah, maybe I'm doing it wrong, but in our SDL code, we have to enumerate all the controllers we want to support and the button layout. So I'm just wondering, where's the config? Maybe we
You may be doing it wrong. Talk to me after the show and we'll work out the bug. It's probably a very simple thing and I know what, but we'll talk about that. Also, I should announce that there are actually bugs in any piece of software, so it might be our fault. We'll fix it. Question.
How would SDL handle a controller with more buttons than an Xbox 360?
It does. How does it handle something that has more functionality, or less, actually, for that matter, than Xbox One? The answer is we provide the functionality. We do it entirely by the configuration that you give it. So if you say this is X and you don't have any trigger buttons, then you just won't ever get trigger button input, and that's the best we can do. We can't physically make buttons appear out of nowhere. If you have more, you have to pick the ones. But like I said, it's a less flexible API. If you're writing a flight simulator, you absolutely do not want to use this. But if you're writing, Super Mario Brothers, or hell, even Pilot Wings, this is what you should be using. It will be much better. Okay, haptic, force feedback. I'm sorry, question.
I actually am using the gamepad support on Android right now. It doesn't show that connected controller as being an Xbox controller, though.
Okay.
The button layout in the native Android.
Okay. Well, like I said, there may be bugs, and it may also be there are joysticks that will show up as joysticks, but not as Xbox stuff. We'll talk about specific problems you're having with the library afterwards. We're running out of time, so let's just keep this to questions for now, and I will talk to anyone after this if you want to talk about a problem you're having specifically. It's no problem. It's probably our fault, and we'll fix it. Okay. So force feedback supports controllers and mice. Most people have gamepads that vibrate, like I said, the Xbox 360 thing, but there is actually standards on some platforms for like Magic Logitech mice that will vibrate on command. And so we do actually have an API that will support either of those, or one or the other, whichever you like. You can do complex effects with it. It can work like the direct input model for force feedback, where you say, do you have sine wave support? Do you have square or triangle and all that stuff? And we will report back what the hardware supports and let you program those things specifically. Or you can just say, I just want simple rumble. I just want the thing to vibrate at this intensity and let me know when you're done. And of course, left-right, which is what anyone who's used X input is used to. You can control the left motor and the right motor separately. We support that also. And there's a fire and forget model. You can say just vibrate this thing for 3 milliseconds, or 3,000 milliseconds, 3 seconds, and then just stop. And don't even let me know. I don't really want to track this and manage it. Just make the thing rumble for a little bit and get back to me, and just keep going. And you don't block on that. You just tell it to do it, and it will continue to do it in the background. That's pretty much all there is to that. It's actually not that hard at all. It's kind of fun because for many years we didn't have that, so I was always stubbing out the force feedback code in video games I was pouring to Linux, and now I can actually have these things vibrate, which is really great. Okay, the audio API. It's extremely low level. The model you want to be thinking of is a DMA buffer from direct sound. It might be too low level, so I'm going to just have the disclaimer at the beginning of this slide. You may not want to use the audio API. This is targeted at people that are writing their own mixers or people that already have, have their own 3D spatialization they've done. All they want to do is push raw, pre-processed, pre-mixed PCM uncompressed data to the audio card. This is what you use. So we've recommended to a lot of people that you use this on the engine that you're building, but the game itself should not be working at this level. It supports, at the moment, mono, stereo, quad, 5.1. We're about to add 7.1 support. 8, 6, 13-bit, unsigned, little endian, big endian, integer, and floating point. These all work. If the system supports these, whatever format you went for, like if you're on Mac OS, Core Audio wants to use floating point. If you're on Wave Out, you probably want to use integer because you're probably using Windows 3.1. And all of these things. You give it whatever you want, SDL will convert it on the fly and hand it to the audio device in the format it wants to be in. It'll resample it for you if it needs to. It'll just, basically you give it what you can produce as a video game and we figure out what to do with it. This works in a callback. This callback usually fires in a separate thread that we've spun ourselves. On really old systems in the last version, like Mac OS Classic, we literally ran this callback in a hardware interrupt, which is a terrifying thing to do. But this, you'll get a callback every time we need more audio data from you, and you just keep pushing audio data in that function and go back to your game without it interrupting it. But really, it's incredibly low level. It's what I call a relentless stream of PCM. If you don't want to work at that level, you should pick something higher because you have to mix this, you have to spatialize it, you have to manage everything yourself. There are higher level tools that might be better, like OpenGL is an example. SDL Mixer is built on top of SDL, but it'll handle like, here's an MP3, play it only on the left speaker, and then it'll convert that, it'll mix that the way that SDL wants it to be. And there's other solutions like Fmod or Mild Sound System. There's lots of good solutions, and that's why we let you turn this off if this is too low level for you. You can do powerful things with this, but the great responsibility comes with blah, blah, blah. Okay, I'm running out of time, so we're going to keep on moving here. The threading API. SDL create thread does exactly what you think it would do. It spins off a thread, and it figures out how to do that on your platform. Create thread on Windows, or pthread create on Linux, or whatever you have available to you. It does one thing that's very interesting that most APIs don't do. You give it a string with a name, and we try to figure out how to make that name show up in your debugger, which is really nice when you have 100 threads. You can be like, oh, there's the one I was looking for. So in that case, and you have to do some really black magic on some platforms to make that happen, so we figured that out for you. We offer all the other primitives you would expect to have if you have threads, mutexes, semaphores, conditions, and most importantly, atomic operations, because everyone's written compare and swap code and been scary. We offer those for you. We figure out how that works on your platform. If the system offers it, if they don't, we can try to do it with opcodes that are specific to your processor and your compiler. You call the exact same SDL function no matter what. It's really scary to try and do that stuff if someone hasn't done it for you. So, and you end up with very platform-specific code. So here you would just call the same SDL compare and swap pointer or integer 32 or whatever. Okay, moving on. Other APIs. These are things I'm not going to cover in great detail, but I'll try to talk about them for a minute or two here. Shared libraries. Everyone's got that if-def in their program if they're cross-platform. If they need to load a DLL, where they call load library on Windows, then if-else Linux, DL open, if-else BIOS if you're still doing that, something else, etc. That's something that's easy to write yourself, but we made it easier. It's always the same thing. I want to open this library. It figures out how to do it. I want to find this symbol in this library. It gives you back a pointer, or null if that symbol can't be found. Very simple. Message boxes, I mentioned before. There is no obviously, there's a native Windows message box function that's easy to call, but there's not an X11 message box that's easy to call. So if you're on a platform that doesn't have one, we'll literally build a window and make it look like a message box like you'd expect it to, so that you don't have to do it. And it's nice for error messages. It's nice for whatever. Sometimes you just need to be like, everything's broken, I'm about to abort this game, I'm sorry. And that's what a message box is for. We can access the clipboard, you can get and set things from it through SDL, and we figure out how that works on your platform. We have something called syswm, which is the fail-safe. In the worst case, you can get a platform-specific window handle and some other things that might be platform specific. So you will have an if-def there, but if you absolutely positively have to get at the system level, we don't hide that from you. You can grab it through this interface so that it, if you need to do some magic Windows call on your Win32 call on your handle to a window, here you go. CPU info, whether you have certain feature sets, what kind of, do we do processor speed? I think we report that too. Things like, does this processor have SSE? Does it have MMX? Does it have AltiVec if you still have a really old Mac or something like that? Standard lib, if you, we have replaced all the things you probably care about in the standard C runtime to make sure that they work everywhere the same. SNPrintf does not exist in the Visual Studio. It might in the newer versions, maybe I'm lying to you. But in older ones, it was never there, and there was this really dangerous SPrintf that you should never ever use. But SNPrintf works great on Linux, so what we ended up doing is having this very simple wrapper that, not also, like I said, on Windows, we never link to the C runtime at all. We provide all that stuff ourselves, including malloc. If you need to allocate memory, we do that ourselves so that we don't have to worry about incompatibilities with the C runtime and different C runtimes that you might be linking against on Windows. But we provide all those functions to you. If you need like a very simple like string compare, it's guaranteed to be there and work reasonably consistently, and if you don't need them, that's fine. You can still call string copy yourself. Timers, if you need to know how many milliseconds have gone by, there's get ticks. If you need performance counters, like you would get from query performance counters on Windows, we provide that interface now. Do you have a question?
Just a quick question on the memory side. Do you provide an option to go directly to the system allocator when you like debug malloc?
He asked if you can go right to the system allocator with SDL. Internally, we don't have an allocator callback. SDL malloc will always do what SDL malloc does. And what does it do on Windows? Do we have like DL malloc in there or something? Sam's laughing, so we'll figure it out. But it's probably a complicated answer. Okay, yeah, but we do, okay, we actually use the Win32 directly, Win32 API directly, but we don't let you override that, but we only use it, obviously, for our own stuff. You're free to use SDL malloc, but you can also not use it. Not the best answer. Maybe we'll put that in 2.1. It's actually not a bad idea. Because we should do that, honestly. Okay, what else? Timers, we just talked about. Read-write ops is a very simple, just interface over file I/O, so you can, if you need to get stuff from different sources, we use it for our own stuff. Like if you want to read a WAV file into SDL for the audio layer, then it takes a read-write ops instead of a file pointer. And all it is just a list of function pointers. So you can say this is coming from a file, or it's coming from memory, or it's coming down a network pipe. It just handles all that for you. You have to supply your own implementation, but it gives you a nice abstract interface, and we use it ourselves for some things in SDL. File systems, where do I read files from? Where do I write them to? Where's the game installed? Where should the users put their save games at? People have been very badly behaved with this on Windows in the past, and Windows is starting to enforce that, and Linux has always enforced that, and Mac OS and stuff like that. So this just lets you figure out, no matter where the platform itself wants you to store stuff, we can find that for you and tell you where your specific game should put stuff. Power is literally, am I on battery? Am I plugged in? How much time is left on my charge in my battery, et cetera, like that. Very important on mobile, very important on your laptop. Not so important on the desktop. It just says there's no battery, presumably. Asserts. We have an incredibly powerful assertion macro. I'm not getting into all the details. There's a lot of magical things that if you're just using assert.h, it's much, much better. There's blog posts about it. The angels sing and weep when we code this thing. And finally, SDL main, which is a very simple piece of C code, which is, it implements WinMain, so that you can simply have, if you want on Windows, you can just have the standard int main, argc, argv. You just do it the same thing on every platform, and we handle the difference between what Windows wants with WinMain and what the rest of the world wants with main. You don't have to use that as an optional piece, but it might make it so that, again, 0 lines of code changes, your existing code just works on a new platform that you don't know much about. In this case, it would be Windows. And some other platforms need that too, but it's mostly an optional thing now. The near future, these are some things that are coming up. Did I forget to take anything out of here? No. None of these are promises of anything, but these are things we want to do sooner or later, and hopefully sooner. Multiple mice, we have the API for it. We do not have it hooked up in the back end yet, but we want to make it so, like you can do with joysticks, you can have 3 mice plugged in on your desk and have each player use a different one. We'll differentiate between them. It's not hooked up yet for most platforms. It will be eventually. Audio capture and video capture, so you can read from a webcam or read from a microphone and do interesting things like that. That'll be a new API, it's not in there. 7.1 audio is coming soon. That just hasn't been hooked up. You don't need to change anything about your code except that you can then use it if you want to by changing just some values when you open the audio device. Wayland support is actually already in Mercurial. It hasn't shipped yet. Mir is coming very, very soon. I'm playing around with libdrc as a fun little side project so you can send your video game to your Wii U gamepad and sit there and play like Super Meat Boy on the gamepad. That's not going to be something you want to ship a project with, but it's just kind of a fun little experiment on the side. We have a Windows RT port, and more importantly, we have compatibility with the Windows Store waiting to be merged into SDL. It's not there yet, but it's about to be, and then you can ship a Windows Store app and pass our certification. We have something coming up called SDL 1.2 Compat, where we're going to take the SDL 1.2 API, the old API, and have it talk to SDL 2 behind the scenes so you get all the new features, but you don't have to even recompile your program. That's going to solve a lot of problems for a lot of people. And finally, the dynamic API, which lets you statically link SDL, and we can still override it if new features come up. So you can, if dynamically linking makes you nervous, we can still make everyone happy there. And finally, your requests here. So if you have something you think should be added to this that would make your experience as a game developer better, we're interested in talking to you, and we're interested in fixing your bugs, and interested in improving this software and continuing to support it and build it out. So if you have something, we definitely want to talk to you after this talk. And crazy ideas are sometimes really good ideas, so don't be afraid. All right, and I think, one last slide here, and then we're going to take questions. There won't be a test, you don't have to memorize these links, but we have mailing lists, we have web forms which are hooked up to the mailing list, so you can use whatever you're comfortable with. They go back and forth. We have a wiki with some really, really good documentation and explanation of everything. We have a Bugzilla that we've gone through over 2,000 bugs in, and we've killed most of them, and we check that religiously. We have a build bot. We build this thing on like 14 different platforms for every single commit we do to SDL, so that if it breaks on a platform, we know immediately, and it nags us very loudly. We take cross-platform support very, very seriously. And then finally, everything else you can find it on the standard www website. All right, that's all, folks. If you have questions, I will take them now for the next... Am I out of time? I took questions all along. If you have questions afterwards, then please see me. I'll be in the audience. Otherwise, feel free to hire me. I'm for sale. This is where you can find the slides. That's my email address. That's my Twitter. And that's my Google+. If you're still using Facebook, man, it's time to reevaluate your life. Thank you very much.